Hi all, this is Mr. Yeager for Honors Chem. We are continuing our mole unit, looking now at molar mass and volume, introducing these two things. So, why are we doing this? Where does this come from? Okay, we've just gone over what the mole is, where we can use this to count atoms. But, like the statement says, there's no way for me to count atoms. Again, I mean, we cannot see atoms, so how are we counting atoms in this case? All right. So, how will this end up helping me in some ways? Well, we have two other values that we can measure, okay? We have molar mass and we have molar volume, okay? Molar mass and molar volume. So molar mass is definitely the more important one. Molar volume we'll cover. We don't end up using it as much later on, but I mean, it's still a good and important, but it's not used huge in high school chemistry, okay? But we will still go through the calculation with it. Molar mass, though, is very, very important. Molar mass, which is measured grams over moles. It's the mass of the object, the mass of the chemical per mole. All right, that's what this is representing. All right. It can be found on the periodic table. We said we were going to come back to it. Okay, so showing this like periodic table picture of lithium. The number at the bottom, usually it's at the bottom of most periodic tables, the decimal number, which we call the atomic mass, or the relative atomic mass, which is the average mass of all the isotopes of the elements. Well, that number right there, which I need to change my pencil to get a different color so you can actually see it, okay? That right there is now also representing what's called the molar mass, okay? The molar mass. So, this right here, what this is saying is lithium has a molar mass that it is 6.938 grams per 1 mole. And so we have figured that out with every single element out there. We know as we go down the periodic table, the elements get heavier. So as you get farther down, you have this. Obviously, if you have the same number of atoms as one that's smaller, they will have a larger overall mass. So that's already given to you on your periodic table. You're not going to have to memorize molar masses. They're ones that you're going to be able to sit there and go, what's the molar mass of oxygen? If I look at oxygen on the periodic table, it says basically 15.99994, which we usually just round to 16. Again, I'll talk about the rounding stuff if you have periodic tables with a lot more decimal places. I mean, basically, let's just go over it now. I like to usually round it off to about 2 decimal places. So since 15.999 can be rounded to 16.00, we usually say oxygen is 16. But if I look at other atoms, okay, calcium 40.08, all right, rubidium 85.47, all right, and all I'm doing is looking at the atomic masses, which I'm now calling molar masses, off the periodic table. And using this value, I can now convert between moles and grams. I can convert between the two of them. Okay? You can see how that's developing. All right? So, that's what molar mass is all about and where it can be found on the periodic table. So, molar volume, which is measured in liters per mole. All right, this one's a bit more straightforward. I don't know why those are commas. I do apologize. There should all be decimals, 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 decimals. I mean, they're going to go away in a second. All right, you can't even see that one now. All right, molar volume, like it does say there, it is a bit more straightforward. It's basically like Avogadro's number, where 1 mole is 6.02 times 10 to the 23rd. It is related to Avogadro's law that at STP, all substances, 1 mole of all substances have the exact same volume, and that is, it ends up being 22.4 liters. I know it's kind of random, but it's one you're going to have to remember, 22.4 liters, just like you're going to have to remember 6.02 times 10 to the 23rd. So, we have another conversion factor that can now convert between liters and moles. So, again, everything is going through the mole, okay, and I'll show you a chart at the bottom, which is really, really good about that, okay? Now, finding molar mass, we already talked about the first one. For an element, you just look it up on the periodic table and write grams per moles after it, all right? And I like to round it off to 2 decimal places a lot of times. You got to follow what your teacher says for that, though. Compounds, what you do is you add up all of the elements that make up that compound. You add up all of the elements that make up that compound. So if I had carbon dioxide, CO2, I have one carbon, and it's 12.01. That's right off the periodic table. Oxygen is 16, but there's 2 of them in the compound. So I multiply 16 times 2. Then I add it all together. 12.01 plus 32 equals 44.01 grams per mole. That would be the molar mass of carbon dioxide, always. So that's usually the first step you're going to have to do on some of these problems when we're converting from mass to mole or mole to mass, is you have to find the molar mass of the compound first. All right? And again, you just add up all of the pieces. Make sure you multiply the subscript by the molar mass of how much is there. Okay? Not the whole thing. I've seen that too. I've seen a lot of people that just add up the elements and they don't pay attention to subscripts. Like you see with the oxygen, we multiply oxygen by 2 because there's 2 oxygens in the compound. Okay? All right. Getting to mole problems now. So here's the general steps, and then I'll be showing you how to kind of go through some of these. Okay? Most mole problems, these mole conversion problems, are either 1 or 2-step dimensional analysis problems. You already saw mole to atoms, atoms to moles. That was a 1-step problem, okay, where you're just doing one conversion. When I say step, it's how many times you have to convert it to something else. The longest these should be is 2 steps, all right? If we're doing any more than 2 steps, something is probably wrong, all right? A couple of hints that go along with this, and I already mentioned this doing the first couple. Mole is always 1 with any other conversion factor. Okay? So 1 mole is 22.4 liters. 1 mole is 6.02 times 10 to the 23rd. 1 mole equals 6.94 grams per liter. I should not see any other number when you're converting other than 1 in front of moles unless it's the initial thing given to you, unless you were given 2.5 moles. After that, I should never see anything other than 1 with the mole, okay? And 2, always start with the number given to you. So again, I kind of already showed this. It's not much different from the ones I showed in the prior video. All right, so you'll see that again. This chart right here is awesome, okay? And I know you can't really see all of them, so we'll do the pieces. The big thing to notice here, basically what I have is this kind of like our mole chart. We have mole in the middle because mole is what connects everything else. All right? Mole can be converted into mass. Okay? Mole can go to mass. Mole can go to particles. Mole can go to volume. Okay? Mole is in the middle, is what we always like to say. You cannot, and this is the mistake I will see some people unfortunately do, okay, every single year, you do not see an arrow that's mass to represent particles, representative particles. That just means against molecules, atoms, and all that. There's no arrow there. And I always will get a student, they'll be like, well, can I just like do it in one step? I know how to kind of put the things together. The answer to that is no, okay? You will have to show your work, and it'll make it so much more clear for you as we make this ever so slightly more difficult when we do stoichiometry, where there's now 3-step problems. All right? We do not convert any of the other units into another unit except the mole. Okay? As you can see by all of my arrows. No, no, no. Okay? You have to go through the mole. So, what we're talking about is, let's say I'm in mass, and I want to convert to particles. What would I do? I'm going to convert to mole first. How do I do that? I'm going to use the molar mass. Okay? So now that I'm in moles, what can I do? I can convert to particles by using Avogadro's number. Okay, 6.02. That looks like 6.62. Okay? 6.02. All right? So that's what we're looking at there. That would be a 2-step problem. I'm going to convert to moles, grams to moles, moles to particles. If I want to change from particles to volume, I would change particles into the mole and then go up to volume using the 22.4. All right? Now again, pay attention to where you are. What if I give you moles and I say go to volume? How many steps should that be? 1 step. Okay? If I say, here's mass, and I want to know what moles is, how many steps should that be? 1 step. So that's the other thing I see people start doing is they make it way too complicated. All right? Use this chart to help you go, okay, what am I in? What do I need to use? What do I need to change into? Okay? And so I know it's a little blurry. We use molar mass to change from mass to moles. We use molar volume, 22.4, to change between moles and volume. And then I use Avogadro's number to change between moles and particles. Do not, please, try to shorten this at all. All right? It does not make your life faster, and many times people will make mistakes, no matter how amazing you might think you're getting through this. Okay? So take your time on it. It is not going to cause any more issues. All right? So let's go ahead and try some problems with this. Okay? And we'll be able to go back and practice some molar masses. So this one's asking you to change basically moles to grams. Grams is mass. So since I'm in moles already, this is going to be a one-step problem. All of these would be one step. I'm only going to do one because I want to do multiple problems here. Okay? So how do I do this? I start off with the number given to me, 0.5 moles of AlCl3. Train track. I do what I did with the prior video on Avogadro's number. What I'm coming from goes on the bottom. What I'm going to goes on top. Mole is with another unit, therefore 1 in front of the mole. Okay? We'll get to it later where if you see moles and moles in the same area, then you can have other numbers other than 1, but that's next unit with stoichiometry. Okay? So, 1 mole, how many grams? Well, what is this? This whole thing at the end here is the molar mass, not just the grams on top. The whole thing is the calculation or the quantity molar mass. So I need to figure out the molar mass of AlCl3. So I need to figure out the molar mass of Al, and I need to figure out the molar mass of Cl, but I need to multiply that one by 3. So Cl is 35.45. All right. And I know that one off just the top of my head. Aluminum is 26.98. So I'm going to add these together. So 26.98 plus 35.45 times 3. Again, just the 35.45. The total molar mass of this is 133.33. Okay, we should always kind of come off, obviously, to the second decimal. So that's what I write up top here, 133.33. And then I can see what I'm doing. Again, when I go across the top, I multiply. When I go across the bottom, I'm dividing. So 0.5 times 133.33. All right. It does come out to 66.665 grams, but this is not a great problem because how many sig figs do I have here? Just 1, so I need to round this all the way to just 70 grams. But that's significant figures. Okay. So 70 grams. Okay. So that's that part. Okay. Moles to grams, and again, you'll see I basically do the same thing. It's not like I'm like jumping off too fast here. But I'm going from moles to grams. I need to find the molar mass. Moles on the bottom, grams on top, because I start with moles, and I solve. Okay? Let's try another one. Let's say I'm in grams. Okay? I'm going to pick a different one so we keep on practicing some molar masses. Let's do this one right here. 2.69 grams of MgCl2. I'm going to go and just continue from there. So I need to find the molar mass of this. Well, I get Cl again, so I know Cl is 35.45. Technically, this is grams per mole. I'll write it this time. But I'm going to multiply this by 2 because there's 2 Cls. Magnesium is 24.305, 24.31. Okay? So 24.31 plus 35.45 times 2 comes out to 95.21. That's a 5. I'll rewrite that. 95.21 grams per mole. Because you will be asked on your test, I'm sure, just solve for molar mass. All right. So how do I set this one up, though? I'm in grams, so I'm coming from grams going to moles. And this is where I see where the biggest mistakes generally occur. As I'll see people write 95.21 on the top. This is moles, though. What goes in front of moles? 1. 95.21 on the bottom. So 2.69 divided by 95.21. I need 3 sig figs, so this comes out to 0.0283 moles. All right. And then, I don't think I actually said it in my prior video. I know it's kind of silly. The mole, the abbreviation for it, for the unit, is MOL. So you just get rid of the E. All right. So you saw me probably do that on the prior video. May have gone, why is he forgetting the E? That's actually the way it goes. You don't write the E. I don't know if we just got really lazy or something, but the unit for mole is MOL. Okay. There's no problem with you going E. You know, that's not going to mark you off, but that's the way it goes. All right. Let's do a gas one. All right. Gas. What you need to remember here is 1 mole is always equal to 22.4 liters of gas, regardless of what it is. So this is like Avogadro's number 1. So I start off with 14 moles of N2. I don't care that it's N2. That's not going to make any difference. I'm coming from moles, going to liters. Moles is with something else other than moles. It's another unit. So 1 on the mole, 22.4 liters. Multiply these two together. 14 times 22.4. That's 3 sig figs. This is 3 sig figs, by the way, because there's a decimal. Okay. So this would be 314 liters. Okay. So we just use that 22.4. If I go backwards, 7.6 liters of helium. This just means liters is now on the bottom because that's what I'm coming from. Moles is what I'm going to. 1 mole, 22.4. You know, again, maybe I'm going too fast on some of these. One of the things a lot of people like to do is if you have a unit up top and a unit on the bottom, you can cross them out. So that's why in the end all I have left is moles. So 7.6 divided by 22.4 is 0.34 moles of helium. Okay, that gives you 0.34 moles of helium. Okay, all right. But one more thing to kind of do, and maybe we'll do 2 of these problems. What about the 2-step problems? So let's say, for instance, that I have, 35 grams of water, and I want to know how many molecules this would represent. 35 grams of water, and I'm trying to go to molecules. All right. So let me go back to my site here. So I'm in mass, and I'm trying to get to particles. What this means is I need to change my mass back to moles first, and then I can change it to particles. And I can do this all together. Not saying I'm going straight there, but I don't need to multiply one thing and then multiply another necessarily. Like I can solve for it all at once. I can combine everything. So how would I do that? So I'm going to go from grams. I'm not going to go straight grams and molecules. I'm going to go to moles and then to molecules. So I have 35 grams of H2O. All right. That's what I'm starting with. And sometimes I tell people, write what you're going to at the very end. Like leave some nice space and write what you're trying to get to. And I would ask yourself, do I have a way to go straight from grams to molecules? The answer is no. There is nothing that will give me grams per molecules of H2O. Okay, there's no conversion straight there. So what I have to do is, since I'm in something other than the mole, I need to get to the mole. The mole is in the middle. So I'm coming from grams, going to moles. Okay? And I mean, let's take our time on this. What is this representing? This is the molar mass. Okay? I know moles will be 1. But what would be the mass of water? Well, I have 2 hydrogens, and hydrogen is 1.01, I guess. We'll keep it as 1.01. All right. And then oxygen, we said was 16. So 1.01 times 2 is 2.02, plus 16 is 18.02. So that's what we put on the bottom. We could solve for this, but what would we be in at this point? If I solve for this, I'd be in the mole. Okay, grams would cancel out. It's on the top and on the bottom. But that's not what I'm looking for. I'm looking for molecules. So let's keep going. I'm in the mole. So I'm coming from the mole, going to. Moles can go anywhere. Okay? Any other unit can only go to the mole, but the mole can go wherever we want. So we can go to molecules now. How many moles would I talk about? Again, 1. Okay, always 1. And molecules, that's counting. I'm counting molecules now. 6.02 times 10 to the 23rd molecules. And I can see then the mole will cancel out because it's on the top and the bottom, and all I'm left with is the molecules. Now, what would I do with my calculation? Everything up top, I'm hitting multiply in front of. Everything on bottom, I'm hitting divide in front of. Okay, that's the method I like to use. Other teachers will say multiply everything on top, multiply everything on bottom, and then divide. Perfectly good. Perfectly good. Not arguing with those teachers. Okay? So, I just like to kind of just keep hitting the divide button. So 35 times 6.02 times 10 to the 23rd divided by 18.02. All right, I started with 2 sig figs. This is going to represent 1 point. Yeah, sorry, I'm looking at this kind of funky. 1.2 times 10 to the 24th molecules of H2O. There you go. That's your 2-step problem. All right, let's try one more. Let's say I have, 2.7 liters of, I don't know. Let's go with we'll go with propane, C5H12. Okay, 2.7 liters of propane, and I want to know what the mass of that is. What would be the mass of 2.7 liters of propane? All right, can I go straight from liters to grams? No, no, no. I can go from liters to moles, and then moles to grams. So how would I do that? I start off with the number given to me. Okay, and I've seen people struggle with that, where they're like, I don't know where I start, and they start with the molar mass. No, okay? I'm in liters, so I'm coming from liters, going to be changing to moles. And I'm going to keep going with this. Sometimes I like doing it this way to kind of show, who cares about the numbers, talk about the process. I'm in liters, going to moles, so that's going to cancel out. And then I'm coming from moles, going to grams, so I can end in grams. Okay? Mole will all be 1. Liters with 1 mole is 22.4. And then I need to find the grams, which is the molar mass. So this is carbon, 5 carbons. That would be 12.01 times 5. And then 12 hydrogens would be 1.01 times 12. .17 grams per mole. So I'm going to put the 72.17 there. I'm going to multiply across the top, divide across the bottom. 2.7 times 72.17, divide by 22.4. This would be 8 points. I need 2 sig figs, 7 grams of propane, C5H12. Okay? You don't need to know the name propane. That's just something that would be given to you if it said it. But that is it. All right? You always have to go through the mole to convert to anything else. Pay attention to the problems where maybe you are ending with the mole, so it's only a 1-step problem. All right? Mole always has 1 in front of it. Liters always has 22.4. Grams per mole is the molar mass, so you have to look at the periodic table and calculate out the molar mass. And that is pretty much it. All right? Good luck to you. Hope everything goes very, very well.